Okay, I think I was thinking today we're going to start with some practice of SQL and then we'll go to the theory for a change. There's a
Okay.
very good website which is called SQL Bolt, and it really helps you writing some complex queries. We'll start from the basics. We already know the basics, so I'm not going to read all of this. This is basically selecting the data. Here are some exercises that we can do. So the first exercise is find the title of each film in this table. So these are your columns. So instead of select all, I'll say title, and this is there's a check you can see here, which means it's correct. Then it's asking me find the director from movies. So director from movies also check. Find the title and director for each film. Let's say title, comma director. That's also check. Title and year. Title and year. Fine. Find all the information about each film. So select all. Okay, so it gives me all the information. This will basically give me result when I type the command. So that's how your first chapter is done. Let's move on. Queries with constraints. Now we know how to select specific columns, but if you had a table with 100 of rows of data, reading through all the rows would be inefficient and perhaps impossible. In order to filter certain results from being returned, we need to use where clause in the query, and the clause is applied to each row of the data by checking specific column values to determine whether it should be included in the result or not. So where, and then you have to put condition, and you can combine multiple condition with and or. More complex clauses can be constructed by joining numerous and or logical keywords. Uh, and below are some useful operators that you can use. Okay, so you can use equal to, not equal to, greater than, less than, between and, not between, in, not in. So let's try it out. So this is a table again, same table. They are keeping the table the same so that we don't have to remember everything every time. So this is our table, title, director, year, length. Find movie with the row ID of 6. So what I want to find, I want to find movie. So I'll put movie here. And from movies where ID equals 6. Uh, ID equals 6. No such column in the movie. Oh, okay, sorry. Find the movie. So I need to get title, not movie. Title. This title is the movie. Okay, so The Incredibles. That was the one with the ID 6. Uh, uh, yeah, here. And that's what it returns. So this is a check here. So that's done. Find the movies. Movies means title. Find the movies released in the years between this and this. So select. I want to find a movie, so I'll be title from from where the name of the table is movies. So I'll put that movies. Now there's a condition where years between 2000 and 2010. So where year is between. So year is greater than equal to 2000 and year is less than equal to 2010. Did I make any mistake? Oh, 10 here. Awesome. Basically, give me all the movies, all the title of the movies from movies table where year is greater than equal to 2000 and year is less than equal to 2010. So that is a check mark. That's correct. Let's go to the next one. Again, find the movies not listed in the years between 2000 and 2010. So I want all the movies which are not between this. So select title from movies where Movies are not released in the years 2000 and 2010. Year is less than equal to 2000 and year is greater than equal to 2000. I don't have to use equal to do this thing between, probably. Let's see. In 2010. Mm, something wrong.
You have to put or.
Oh, yeah. I have to remove equal to, I guess. Okay. So give me all the movies where year is greater than 2000 and year is, sorry, year is less than 2000 and greater than 2010, which means it'll only give me movies below this year and after this year. That's the meaning of this where clause. Thanks, Amaya. Okay, so next, find the first five Pixar movies and their release year. So, what is Pixar movie? What is a Pixar movie? First five Pixar movies and their release year. Select title from movies. Uh, Title, and we want year also. Limit 5. Yeah. Pixar is just saying movies. Pixar is nothing specific. Uh, so it's just saying give me five top five movie, first five movies. So there's a limit that you can use for that. Limit 5 which is give me first five. Cool. So we'll move on to the next chapter. So queries with constraints. When writing a where clause with columns containing text data, SQL supports a number of useful operators to do things like case insensitive, string comparison, and wildcard pattern matching. We show few common text data specific operators below. So, for example, column name equals this. So, when we are trying to match the string, we'll put that in quotes. If we are trying to match the ID, then we'll put that without quote. Like in the previous example where we said get me the movie with the ID number, that's when we don't didn't use the quote because that was a integer. But here it's a string, so we'll use double quotes. Okay, case sensitive exact string inequality comparison. Notice this single equals. Okay, this is case sensitive. So if you use equal to, then in the database going to be case sensitive, which means it has to be in small letters. But if you use like, then it's not going to match the case sensitiveness, which means even if it's small letters ABC, it's still going to match because you're saying like, you're not saying directly equal to. Not like, which means inequality comparison. Then you have percentage, use anywhere in a string to match a sequence of zero or more characters. So this will match at, attic, cat, bats, which means if you put this percentage before and after, it means it'll match at anywhere between the words. If any word contains at in between, in the beginning, at the end, it's going to match that. Then we talk about used anywhere in the string to match the string characters, only like and not like. So like this, okay, matches and but not an. Okay, you still match any single character, only like and not like. Matches this but not that. Okay, so I guess it's saying that find a match with this with followed by any other character. But it has to follow. If it doesn't follow, then it will not match. String exists in the list. If you use in, which means whether or not that particular string exists. String does not exist in a list, so you say not in. Okay, let's try some conditions. Find all the Toy Story movies. So we'll do select title from movies table, where title equals Toy Story. Did I make any mistakes? Find all the Toy Story movies. What did I do wrong? Uh, okay. So there's a Toy Story 3 also. So we have to do something like percentage here. Why that
I
not
think
match?
you have to use like the title
Oh,
like.
yeah, you're right. Perfect. So equal to will not work with percentage. We have to use like explained over here. Percentage means this text should appear anywhere in the text. So that's why we got all the results. Now find all the movies directed by John Lasseter. So select title from movies directed by. So is that author or what? Director. Okay. From movies where director equals John Lasseter. Yeah. So this will be giving me all the titles where the director is John Lasseter. The next is find all the movies and not directed by. Okay, so I want all the movies. Select. I want all the movies, which means I want title, and I also want the director. Okay, from movies where not directed by. So which means director not equal to John Lasseter. Spelling. Yeah. Okay. So give me all the movies who's directed by anybody else, but not John Lasseter. So we use not equal to sign here. Find all the wall movies. What's okay? These guys. So wall will be in the title. So select title from mo- from movies where title like oops uh, wall. Okay. If I put like that, work. Yeah. Okay. So here is showing that in the beginning it should be wall and then followed by anything else. It doesn't matter. Doesn't care. Should begin with. So that's why we put wall and after that percentage. Percentage means it can follow anything, any character after that. And we use like because we are not looking for an exact match in the text. We're looking for a kind of a preg match. Okay, I think that's it for practicing for today. Tomorrow, we'll continue the, 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 lesson 4, and keep that link. So try to practice on SQL board is very useful website, and it'll give you advanced topics like joins and all that stuff as well. It's very good at that. Most of the websites, many websites are actually chargeable. When I There's W3 school also, but I didn't quite like that much as compared to this one. Okay, so let's move on to the object-oriented programming. Sorry, database management. So, Kritika, I put one task for you. I hope you had a chance to look at it.
Oh no, I didn't. But I will look at it now.
Okay, no problem. So all I'm saying is that anywhere you see a star here in the title, just change the color by going to slide and then change background and then select this color. Because that will help us easily identify which, because by looking at it it's maybe difficult to identify the stars, but in the menu itself we can look at the color of the slide background and then easily find out which are the ones we need to practice from tomorrow. Okay.
All right. Okay.
Yeah. Okay, let's start with a recap and then we'll move on from there. Okay, so advantages of the database management system. uh, Database management system creates and manages databases. With the help of database management system, programmers can easily retrieve, create, update, and manage data. The various functions performed by database management system, which gives an upper hand over traditional file system. Users can also create personal databases as per requirement. So when you get this question in examination, think about comparing it with the file management system. So then you can recall what are the differences. Like for example, in file management, there's a duplication of files, but in data management system, we use normalization to ensure that there's no redundancy, there's no duplication. Um, in file management system, one user is assigned to a particular folder. Here in database management system, uh, it decides which user will get how much access of the database. So things like that. Okay, so ease of accessing data. In file system, different files are created for each user which they can access. DBMS removes the redundancy by granting access to users and decides how many parts of the data is accessible to them from the database. Storage and management of the data. Unlike file system, data can be directly stored in form of objects in DBMS, making it easy to query. And we can also use it for object-oriented programming. When you have the data in form of objects, just easier. Avoid duplicates and redundancy in file system. Storage of data might happen multiple times. There could be multiple files with the same name in the same folder, but data normalization is used in DBMS to avoid duplication of data. So in the data normalization, in case if there's duplication, we create multiple tables to ensure we have efficient data management. Concurrent data accessing, users can access data simultaneously through different applications. Database integrity means data should be accurate and consistent, and by enforcing the checks and constraints, ensuring there's no data loss. Data of the database is not allowed to violate these constraints or rules. For example, a constraint on age of an employee can be between 18 to 70 years only. While entering or modifying the data of the age of an employee, DBMS should enforce this constraint. Okay. Types of database management architecture. So you have logical and then you have physical. Uh, Logical architecture defines the data organization and access at different logical levels of a database. Example, three-level architecture of DBMS. And physical architecture defines various components of DBMS software. Example, DML precompiler, DDL compiler, file manager, database manager, query processor, database administrator, data files, indices, and data dictionary. Three levels of database architecture includes the internal or physical level. conceptual level and user or view level, sorry, external or view level. The three-level database architecture of a database was designed by ANSI for data abstraction for different types of users. You have physical or internal level, conceptual or logical level, external or view level. So physical and internal level is the very first level. It decides how the data is going to be stored, and data is stored in form of bytes into the hard disk. The physical level also discusses compression and encryption techniques. Then you have the conceptual level. This conceptual level is at a higher level than the physical level. The purpose of conceptual level is to define the structure, relationship, and the constraints of the database system. It describes how a database appears to the users conceptually and relationship between the database tables. It doesn't care how the data is stored into the database. This is the highest level in the three-level architecture and closest to the user. It only shows the relevant database content to the user in form of views and hides the rest of the data. So different users can see the database as a different view as per their individual requirement. Okay, we talk about data independence, which means that a change in the data at one level should not affect the other level. So we should be able to modify the schema at one level of the database system without altering the schema at the next higher level. The three-level architecture defines a single database system across three levels. Be uh, Therefore, different levels must map with each other. This mapping leads to the concept of data independence. There are two types of data independence: physical, uh, which is defined as the capacity to change the internal schema without having to change the conceptual schema. If you do any change in the storage size of the database system server, then conceptual structure of the database will not be affected. Physical database independence happens at the conceptual level. It is used to separate the conceptual levels from the internal levels. Then you have logical data independence. It refers characteristics of being able to change the conceptual schema without having to change the external schema. Logical data independence is used to separate the external level from the conceptual level. If we do any change in the conceptual view of the data, then the user view of the data will not be affected, and it occurs at the user interface level. This is your physical database architecture. The number of keys functions which are similar to most of the database management system. The components that normally execute these functions are shown in the figure. DML precompiler. Every DBMS consists of data manipulation language DML, which is used for data insertion, modification, data access. The purpose of DML precompiler is to translate the DML commands which are written as a part of the application program into related procedural calls so that they can be executed to perform desired operation. In addition, the component of the DBMS also coordinates the translation of queries which are input to the query processor component. DDL compiler is used to compile DDL statement into related tables, which includes metadata, constraints, and access rights. The metadata tables are stored in the data dictionary or system catalog. This metadata is used for providing information about tables to other components of DBMS, protecting data and enforcing data integrity. So DML precompiler translates the DML commands so that they can be executed to perform the desired operation, and DDL compiler is used to compile the DDL statements into related tables. Ritika, can you read this?
Yes. I've also changed the colors. That's done. Um, okay. Physical DBMS architecture software components. File manager. All the tables and metadata of the database are physically stored as files under the control of file subsystem of the operating system. The file subsystem of the operating system has generic features which may not be sufficient for a DBMS file. The file manager component of the DBMS keeps track of all the data files, the index files, and all other related information files of a database system. Database manager. The role of a database manager is to accept the requests of data access or data manipulation by the user queries and application programs and performs the relevant action on the data taking the help of data dictionary and file manager. Database manager protects the data from unauthorized access and manipulation. It also enforces integrity constraints.
Okay. Sumaya, do you know what is data integrity?
I'm not sure. Maybe it's referring to the integrity constraints. Uh,
Yeah. Ensuring all the rules are applied, ensuring there's no data loss. So all of this refers to the data integrity.
like the primary key is not null. That's an integrity
Yeah.
constraint.
Yeah, constraints. Okay. Right. So file manager keeps track of all the data files and their index files and all other related information files. Just in case if we get short notes, we can think of the files. Uh, so manager does what? Like manages files. So we can think in those relation and probably we can write something. Keeping track of the file, their index files, all related information files of the database system. Database manager job is to do everything, basically accepting requests of data access by the user queries, performing relevant action like deciding who will get the access, who will not get the access, protecting data from unauthorized access manipulation, enforcing all the constraints are met, all of that job. Go on.
Major components of database manager. Authorization control is used to verify the credentials of a user to ascertain if he or she is an authorized person to access or modify the data. Command processor converts the DDL or DML or other programming language commands to executable sequence of code. Integrity checker checks if the data is being inserted in a database or is being modified, follows all the specified constraints on the database. Query optimizer tries to optimize the processing time of different queries. Transaction manager is one of the most important components, which checks if the user has the right to perform a transaction. Scheduler component manages the consistency of data while concurrent transactions are being processed by a database. Recovery manager is responsible for recovery of a database system to a consistent state in case of a failure. Buffer manager optimizes the process of transfer of data between main memory and the disk where database is stored. The buffer manager is also termed as the cache manager.
Okay.
Query processor. Every DBMS consists of a query language which enables database creation, data manipulation, data retrieval, and data control operations. In general, this query languages processes consist of two basic components. The first one passes the query language into the native database language, and the second optimizes the query and prepares the code for query execution.
There's a whole chapter on query processing. So we'll discuss in detail there. And there's a question about query optimization in the exam. We'll talk about that as well.
The parser checks
Sumaya,
the
just one second. So Maya, can you do one thing? When you go through the star questions, the ones that are starred, just review their content, and if you feel they're appropriate for writing in the exam, of course we are anyways going through them, but there's a lot more slides in this DBMS.
Okay.
So only the ones which are star marked are from the question paper as well as from the assignment. So just review
Mhm.
them. If you feel more content needs to be added, or uh, you know, uh, or it needs to be changed, it's not correct, then keep a note with yourself in the comment, and then we'll discuss that tomorrow.
Okay, sure.
Yeah.
The parser checks the syntax of the query. converts the query to a sequence of tasks, and sends these tasks to the query optimizer. The query optimizer is responsible for generating a set of alternative query evaluation plans. Database administrator. The role of DBA is to monitor control the database creation at different levels of three-level architecture and mapping between the levels, modification, access, query response time, security, recovery in case of failure, etc. Data files, indices, and data dictionary. Data files, the data is stored in data files. Data files can be standard files or encrypted files. These files in general are not accessible directly to any system user. Indices are stored in index files. Indices provide fast access to data items. Data dictionary or directory is designed to store metadata, which is data about data in a database system. A good data dictionary allows efficient data access as it can provide a roadmap to guide users to access information within a large database. A database system requires that the data should be structured in such a manner that it allows easier data access and manipulation operations. These structures are termed as database models. Conceptual model uses entities, their attributes, and relationships among entities. Hierarchical model uses data hierarchy. Record-based logical models. Object-based models uses objects as key data representation components. Semi-structured model uses user-defined tags. Database backend. Most of the database systems are deployed in a multi-user environment, either as centralized or distributed system. A database server, which is at the backend, manages and controls the physical data. It also provides integrity, security, and access control to multiple clients' requests. Need of utilities in commercial database system. Utilities are special purpose software which are provided to support additional features in support of a DBMS. Two such utilities are for backup and or restore, to protect data against any failure, and load unload, to load data from one hardware or software. Difference between network and hierarchical model. A network model stores of basic entities as data records, and points are used to represent the relationship between them. A hierarchical model uses almost similar model to represent data of entities, but the relationship between them is implemented as a hierarchy.
Okay, we'll talk
Relational
about relational
database.
database management system. Yeah, go on.
A RDBMS is based on a relational model introduced by EF Cord. Example SQL, MS SQL Server, IBM DB2, Oracle, MySQL, and Microsoft Access are RDBMS.
Okay.
A RDBMS database uses tables to store data.
Hmm.
Each table is called a relation, which is a collection of related data entries and contains rows and columns.
Okay.
Each table represents some real world object, such as a person, place, or event about which information is collected.
Okay, so I'll just recap this. Relational database management system is based on relational model introduced by EF Cord. Example is SQL, MySQL, MS SQL Server, Oracle, Microsoft Access. These are the examples. And each table is called relation, which is a collection of rows and columns, which is related data entries. Each table represents some real world object such as person, place, or event about which the information is collected. uh, Difference between relational database management system and object oriented database management system. Yes, Kritya, go on.
RDBMS and object oriented DBMS.
Mm-hmm.
RDBMS stands for Relational Database Management System. OODBMS stands for Object Oriented Database Management System. For RDBMS, data is stored as entities defined in a tabular format. In OODBMS, data is stored as objects.
Yeah.
Um, RDBMS handles simple data. OODBMS handles large and complex data. An entity refers to a collection of similar items having the same definition. A class refers to a group of objects having common relationships, behaviors, and properties. RDBMS handles only data. OODBMS handles both data and functions operating on the data. To RDBMS, the objective is to keep data independent from application program. OODBMS objective is to implement data encapsulation. A primary key identifies an object in a table uniquely. Object ID (OID) represents an object uniquely in a group of objects.
Hmm. By learning this, you'll be able to solve another question, because there are two questions, I think in assignment or exam paper. One talks about the difference between these two, and there's another where you have to talk about the object oriented database. So you'll be able to get information from here and write an exam. Of course, the full form is easy. The key thing you have to remember about these two is that relational database management system is to do with storing the data in form of entities, in form of tabular format. There's tables. And object oriented database management system, as it's clear from the name, is that it's storing the data in form of objects. And yes, when I was reading about the object oriented, there was a limitation discussed about relational database management system, is that uh, when we are dealing with complex data, relational database management system, the way it solves this redundancy is that it creates too many tables. But in object oriented database management system, you can create just one object, and you can extend it with inheritance. You can extend those classes, and just handles the complex data a lot easily. Another advantage would be that in object oriented programming, if the data is already in the object form, then it's just easier to use it. Um, yes, and an entity refers to the collection of similar items having collection. Class refers to the group of objects. RDBMS handles only data. OODBMS handles both data and functions operating on that. Objective is to keep data independent from application program. OODBMS to implement data encapsulation. RDBMS uses primary key, and OODBMS uses object ID. Okay, go ahead and explain this whole thing.
Uh, each row of the table is called a record or a tuple. So every horizontal that we see it is can be counted as a record.
Mm-hmm.
Each column is called an attribute. So rows are records and columns are attributes. A domain is a set of permissible values that can be accepted by a specific attribute. So, for example, for a salary, the range can only be what we specify as accepted value.
Mm-hmm.
The number of columns in the database is also known as the degree of the database, and the number of rows is called the cardinality of the database.
Okay, good.
So yeah.
Perfect. Let's move on. Okay.
Database relation. The total number of attributes that comprise a relation is known as the degree of the table. For example, employee table has four attributes and its degree is 4. A superkey is an attribute or set of attributes used to identify the records uniquely in a relation. Um, Example, employee ID is a super key since employee ID is unique for each recorded tuple. Similarly, uh, employee ID, ename, and employee ID post are also super keys of the relation employee since their combination is also unique for each tuple or record.
Okay. So can post and salary be together a super key?
They cannot be because then they don't uniquely identify it.
Hmm. Right. Okay.
A candidate key is a single key or a group of multiple keys that uniquely identify rows in a table. Example, both employee ID and name can act as a candidate for the table as long as they contain unique and non-null values. Candidate key should be as small as possible. Difference is that candidate key is not reducible, which means after removing one attribute, the other attribute should not unique itself. Example here,
Hmm.
employee ID plus employee name together cannot be a candidate key because employee ID alone can be a unique key. So employee ID plus ename is reducible.
Right.
Basically, it is the smallest subset of the super key,
Perfect.
and there can be multiple candidate keys. And
Okay.
one of the candidate key is selected as a primary key,
Hmm.
the ones that is most appropriate. So primary key is a candidate key selected by the database administrator to uniquely identify tuples in a table. Out of all the candidate keys that can be possible for a table, there can only be one key that will be used to retrieve unique tuples from the table. For
Okay.
example, employee ID and name are candidate keys, then employee ID can be chosen as a primary key.
Okay. Sumaya, if you check the question paper, there are questions about the normalization. You can see define first normal form here. Are there any others? Yeah, here you have second and third normal form, right? So it looks like there could be the high chances in exam they will ask us about normalization theory, right?
Yeah.
Considering these are going to be for 6 marks and these are going to be this is for 2 marks. Can you in the same slides? I have not spent much time in normalization. So wherever that normalization is uh, in this presentation, maybe you can add some content and can you take us through tomorrow with the normalization? Just explain using the slides and so that we can remember those and write it in exam.
Yeah, I'll do that.
Okay, we'll start with the normalization tomorrow. Okay, and then we'll go
Okay.
on practicing the SQL Bolt. Okay, so where were we? Mm, we were here. Okay. Yes, Kritika.
A relation. A relation
Mm-hmm.
is defined using two basic aspects. A relational schema specifies the relation's name, the list of attributes of the relation, and the domain of each attribute, which is denoted as R, A1, A2 till AN.
What are these A1, A2?
Attributes,
Correct.
the columns.
Perfect. And what is R?
Uh, a relation between them.
Let's say if I have to write a schema for a relation called student, and it has two attributes. One is student ID, and second is student name. So how will you write that a relation schema for that using this formula?
Uh, we have student ID and
Student ID and student name are the attributes, and the name of the relation is student. So using this formula, how will you write it?
I
So
don't
just
know.
replace this. You just replace this. So what is it saying? Relation schema is nothing but relation name and list of attributes. Look at this. So here this is relation name and this is attribute. Just replace that. So this will be replaced by the relation name. So what is the relation name I said? Relation name is student. So you'll put student here. Then you'll replace the attributes. So here it's A1,
Student.
A2. There it's student ID and student name. So you'll put that. That's it. That's your schema. Okay.
No, okay, yeah.
Yeah.
The relation R has n attributes, which is also called the degree of a relation. For example, the relation schema of the relation person can be defined as person, person ID, integer, name, character, age, integer, address, character.
Understood. So what are they doing? They're replacing R with the relation name
Person.
person. So R is replaced. A1, A2 is replaced with attributes. Attributes is person ID, name, age, address. You can also write the type by separating them with colon. Data type.
Since the person relation contains 4 attributes, so the relation is of degree 4. Relation instance or state is a collection of tuples for a given relation schema at a specific point of time. A relation state R of the relational schema R A1 A2 till AN is denoted by R. R is a set of n tuples. R is equal to T1 T2 till Tm has m tuples, where each n tuple is an ordered list of n values.
Yes. So difference between relation schema and instance is that relation schema specifies relation name and the list of attributes. Instance is just collection of tuples, which is collection of rows. So you denote name this as R equals and then row 1, row 2, row 3 up to row n. Okay, so this is the example. Relation schema for a student will be student, roll number, name, login, age. These are attributes. An instance will be T1, T2. So it'll be T1 will be this whole thing, and T2 will be this whole thing. So, Pritika, what are the different attributes of relation S?
Attributes S number, S name, and city.
Yeah, how many tuples does S have?
Two tuples.
Correct. What are the domains of attributes S?
Uh, Domains of attribute S.
Domain, we remember
Um,
is a range, right?
yes, the range. So it will be like for example the it'll be like varchar and the number that we specify.
Uh-huh. So here they have not specified like what will be the range, but we have to assume. So we can see a pattern here. We can see that in every ID they're starting with S. So we can say that starts with S and then it follows a number 1, 2, and 3, and could be a string. Then domains of S name will be the name of a certain length in characters. Domain of a city will be the list of will be the city, any city from India. Okay, so that's what it's talking about here. All possible cities of India. This is just assumption because they have not specified. On sorting this relation on the field city, will the relation change? The whole relation, of course, will not change. But if you sort it by city, maybe alphabetically in reverse order or something, the order of tuple, order of row will definitely change. List all the super keys, all possible candidate keys, and primary key of the relation. So, Maya, what are all the super keys in this?
S number, S number plus S name, S number plus S name plus city.
Mhm.
Also could be S name alone if the names are unique.
Okay, so all possible combinations. Candidate key,
Candidate key is S number or S name.
as long as they're unique.
Yeah.
Okay, primary key is S number. That's very obvious. Okay, relational constraints. So relational constraints and types of constraints. On modeling the design of relation database, we can put some restrictions like what values are allowed to be inserted, modified, or deleted in the relation. These restrictions that we impose on the relational database is called relational constraints. The literal meaning of constraint is, to limit. Okay, put limitations, put restrictions. So when you know this, you can describe it that when you're talking about the relational database, we can put restrictions on it, like what can be inserted, what can be modified, what can be deleted, and these restrictions that we impose on the relational database are called relational constraints. Constraints are of following types. Does anyone remember what are the different types of constraints? Anyone?
Key
Uh,
constraint,
Domain
Sorry.
constraints and integrity constraints,
Okay. The domain
referential
constraints,
integrity constraint.
referential integrity, yes.
that are the types of integrity constraints, right? The main one are domain constraint, key constraint, and integrity constraints. Okay. There are more in the like on internet, but I will go by the book, whatever is written in the book. Book has three, so I'll just use three. So domain is to do with the range basically, and data type, etc. Key is to do with the key, which has to be unique, and integrity is to do with the uh, let's see what integrity is. So domain constraints. You have to give example also in the examination. So try to remember not the exact example, but try to remember what example you will give in the exam. These constraints bind the possible values of the attributes in relation to a specific set, called the domain of the attribute. Every domain must contain atomic values which cannot be divided into sub-values. This means composite and multi-valued attributes are not allowed. So these constraints bind the possible value of the attribute in relation to a specific set of a data type called the domain of the attribute. So just saying that they define what will be the possible value of particular attribute in that range, in that domain. And every domain must contain atomic values, so you cannot divide uh, it into sub values according to domain constraint, which means here Bikash Datta. So first name and last name, you can divide it. You can break it into first name and last name. So it's not meeting this requirement. So it's not following that. So it's failing this constraint rule. Then it says this means composite, which means which cannot be divided into sub parts, and multi-valued attributes are not allowed. Multi-valued means two value. So here phone number is two value, one and two. So this is again not allowed according to domain constraints. So in the above relation, name is a composite attribute, which means it can be broken down further into first name and last name. And phone is a multi-valued attribute, so this is violating the domain constraint. So this is not correct. A correct would be name, Bikash, and then phone number, just one phone number, according to the domain constraint. Key constraint. The constraint states that the key attribute value in each tuple must be unique, and no tuple can contain the same value for the key attribute. This is because the value of the primary key is used to identify a unique tuple in a relation. In the below example, EID is the key attribute, and because the first and the third tuple have the same EID, that is why again it's violating the key constraint, because key constraints straight away says that the key attribute must be unique for each tuple, and no two tuple can have the same value for the key attribute, because key is something we use for identifying a particular record, so there shouldn't be duplication. So that's why it's not following. If I remove this third tuple, then this table is correct and it'll be following key constraints. Or if I make this to 3, then it'll be fine. So again, you can elaborate on that in the example. Okay, integrity constraints, there are two types. One is entity integrity constraint, referential integrity constraint, which Sumaya was talking about. So entity and integrity constraint. It states that any attribute of a primary key cannot take a null value. This is because primary key is used to identify individual tuple relation. Okay, so any key cannot take a null value is what is said by entity integrity constraint, and you will not be able to identify records uniquely if they contain null values. Because let's say I want this record, so how will I identify? I don't have a key, I can't access this. In the below example, if A is the primary key, the first record tuple violates the entity constraint rule. So the main thing you need to remember for entity integrity constraint is that the primary key cannot be null. The rest of the information is just an explanation of the same thing, an example. Then you have referential integrity constraint, which says that when you have the foreign key and the primary key, so those should be so primary key should be available in the other table with the foreign key. Specifies between two relation or tables and used to maintain consistency among tuples in two relations. It is enforced through a foreign key. When an attribute in a foreign key of a relation have same domain as the primary key of the relation R2, then the foreign key is set to refer to the primary key of the relation. In this example, every value of C in instance R is matching with the value of C in instance in some tuple. So that's why it does not violate. So every value of where is that? 1 second. Every value of C in an instance R is matching with at least one of these tuples value in C. That's why it's not valid. The R containing values of C1, C2, C3, and S contain these values. Thus, instance R and S do not violate the foreign key. So this is the thing. So differential integrity constant talks about matching of the primary this one of the keys here and then the foreign key. So why constraints should be defined in database management system? Defining constraints prevent the bad data. They enforce business logic at the database level. They provide documentation of important database rules. They enforce relational integrity between number of tables. They improve database performance, enforce uniqueness. Prevent bad data, enforce business logic, provide documentation, enforce relational integrity, improve database performance, and enforce uniqueness. Dealing with constraint violation. I think we did this. We don't have to go through it too much. It just talks about that in case if there's a violation, then you should give the message to the user like, what is the violation? What's the reason for the violation? How to solve it, etc. So we'll just move on. Okay, relational algebra. Relational algebra is a set of basic operations used to manipulate data in relational model. These operations enable the user to specify basic retrieval requests. The result of the retrieval is a new temporary relation which is computed after performing operations on one or two relation. We'll wait for 2 minutes. Prayer is going on. Okay, let's begin. They said you overused the account of StreamYard, so you finished your hour for the month. I said, don't worry, we are in India. We use Jugaad, so I changed the email ID and created another account on StreamYard. Am I on mute? No. The screen is getting shared now.
Yes, yes.
Okay, relational algebra is a set of basic operations used to manipulate data in relational model. These operations enable the user to specify basic retrieval requests. The result of retrieval is a new temporary relation which is computed after performing these operations on one or two relations. Some of these operations can be classified in three categories: a relational operation. These can be unary operation, selection, projection. Then you have binary operations, which are Cartesian product, join. Basic set operations. These are binary operations that are used to merge two sets in various ways. Two relation R and S are said to be union compatible if they have the same degree n, and domains of the corresponding attributes are also the same, which means the number of columns must be the same for R and S relations. Only then they are said to be union compatible. So that's a rule for basic set operation. Okay. Selection is a unary operator that is used to choose only those tuples from a relation that fulfill the given criteria. It is represented using the mathematical symbol. I think this is a sigma symbol as given below. It couldn't take that symbol here, I guess. Couldn't paste that. I guess that's the symbol. Okay. Selection is a unary operator that is used to choose only those tuples from relation that fulfill the criteria. It is represented using the mathematical symbol sigma as given below. So let me copy that. It should be here. Example, sigma place equals Mumbai or salary is greater than equal to 10 lakhs, 0 to 100,000, 10,000 lakh, yeah, 10 lakh. And citizen is the relation name. Another one is age less than equal to 30, and relation name is person. So here, consider relation person. If you want to display the details of the person having age less than or equal to 30, then the selection operation will be used as follows. So sigma is basically used to denote select. So select where age less than equal to 30 from the relation person. The resultant criteria will be as follows. Person ID is 2, name, age. So this is basically going to give you all the attributes where this condition is met from the relation person. Note, select operation is commutative, which means you can combine multiple relation. Hence, you can apply a sequence of selection operation in any order. You can apply more than one condition by using logical connectors. So this is an example of a relational algebra. You can use these signs to denote the selection. I'm not sure if this works on command line interface or the program, but I guess this is for writing purposes. The projection operation. So Earlier we saw selection, now we are seeing projection operation. The projection operation is used to select specific attributes amongst all the attributes of records. It is denoted by pi. So pi, and then whichever attribute you want to select, and then the relation name. So this is going to give me name, all the names from relation person. Okay. Projection is used to project the required column data from a relation. So difference, I would say here, this was choosing the tuples. You can see the whole row is there, and in the selection and in the projection, it is selecting specific attributes, which means specific columns. So this was to do with the row, and this is to do with the columns. Giving you only that particular column in the projection. So it projects that column basically. Then you have Cartesian, which is cross product. The cross product between two relations, let's say A and B, will result in all the attributes of A followed by each attribute of B. Each record of A will pair with every record of B. So resultant relation will be equal to A into B. So we'll start with this tuple. It's going to put that tuple in. Of course, first it will put all the attributes, which is name, age, sex, ID, course. It'll put everything there. Start from here, adds that, and it's going to start from the first tuple. It'll add that, then it'll again repeat the same thing, and it'll add the second tuple. If there was third, it'll add the third also, and go so on. So this has to be a product of the two. So this will result in all the attributes of A followed by each attribute of B. Then you have join. Join operation combines the relation R1 and R2 with respect to a condition. It is denoted by, I don't know what that symbol is called, but the different types of the join operation as follows. Theta join combines tuples from different relations provided they satisfy the theta condition. The join condition is denoted by symbol theta. Equijoin, when theta join uses only equality comparison operator, it's said to be equijoin. Natural join, at least one common attribute should exist between the two relations, and the attributes must have the same name and domain. Then union operation, the result of union operation, which is denoted by A union S, is a relation that basically includes all the tuples that are present in A or in S or in both, eliminating duplicate tuples. Intersection operation is a relation basically includes all the tuples that are present in both A and S. And set difference means that relation basically includes all the tuples that are present in A but not in S. So union means it has to be present in A or S or both. Intersection means it has to be present in both. And set difference means that it should be present in A but not in S. Okay, we talk about entity relationship model. Every entity relationship model is a high level conceptual data model. It allows you to describe the data involved in real world enterprise in terms of entities and their relationships. It is widely used to create an initial design of the database. It provides a set of useful concepts that make it convenient for developers to move from a basic set of information to a detailed and precise description of information that can be easily implemented in the database system. It describes the data as collection of entities, attributes, and relationships. So this is your ER model. The student is an entity. These are your attributes, entity, attribute, relation. So what is an entity? An entity may be an object, class, person, or place. In ER diagram, an entity can be represented by rectangles. A strong entity is the one which is not dependent on any other entity, like for example loan, and is denoted by a single border on the rectangle. A weak entity is an entity which does not have its own primary key and is dependent on another entity. That's your weak entity. There's a question in the exam to write short notes on weak entity. So you can write about it, and then also mention that it needs to be double border in on the rectangle. Entity set, a collection of similar kind of entities is called entity set or entity type. A collection of all student entities form an student entity set. Entity identifier, an attribute or a set of attribute which contains unique value for every distinct entity in a set is called key or attribute, and its value can be used to identify each entity uniquely in the given entity set. Weak entity, entity that depends on another entity, is called weak entity. A weak entity doesn't contain any key attributes on its own. The weak entity is represented by double triangle, sorry, double rectangle. Strong entity, an entity set which contains at least one key attribute, is a strong entity set. For example, a student entity set would contain at least one key attribute enrollment number, which is unique for every student. Thus, the entity set student is a strong entity. So you can also give example like that for a weak entity if you get a question like that in the examination. So Maya, can you read this?
Yes. The attribute is used to describe the property of an entity.
No, it's not there.
Ellipsis.
Okay. Kritika, are you there?
Oh,
Yes,
can you hear me?
yes, I can hear you both.
The attribute is used to describe the property of an entity. Eclipse is used to represent an attribute. For example, ID, age, contact number, name can be the attributes of students. Types of attributes: simple, an attribute that cannot be further divided into small parts and represents the basic meaning. Example, each of the attributes, first name, last name, age, entity, set, person, are simple attributes. Composite, an attribute that is composed by dividing into many other attributes. The attribute name of the student entity can be subdivided into first name, last name, and middle name. So simple one is which cannot be divided, like your first name here. Composite, which can be divided, so like name here. Single valued, which contains only single value, for example, age of a student. Multi-valued, which is the one that contains multiple values. Derive means an attribute that's derived from another one. For example, age can be derived from date of birth. Relationship with ER diagram. Relationship is used to describe the relation association between entities. Diamond or rhombus is used to represent the relationship. Example, in teacher entity, student entity, teachers is association or relation between them. You have one-to-one relationship when only one instance of an entity is associated with the relationship. For example, a female can marry to one male and a male can marry to one female. One to many when only one instance of an entity on the left and more than one instance of the entity on the right associates with the relationship. For example, scientists can invent many inventions, but an invention is done only by a specific scientist. Many to one relationship when more than one instance of entity on the left associates itself with only one instance of an entity on the right. For example, students enroll only for one course, but a course can have many students. And you have many to many relationship when more than one instance on the left and more than one instance of an entity on the right associates with the relationship. Example, an employee can assign many projects, and projects can have many employees. Cardinality of the relationship means the number of instances of an entity associated with another entity participating in the relationship. Based on the cardinality, the binary relationship can be further classified into following relationship categories: one to one, one to many, many to one, many to many. Degree of a relationship set is a number of participating entity sets. The relationship between two entities is called binary relationship. A relationship among three entities is called ternary relationship. And similarly, you have n-ary relationship. Recursive means both the participating entity sets are in the same entity set. However, the role of entity set is in each participation is different. Participation constraints specify whether the existence of an entity depends on its being related to another entity. Types of participation constraints, for example, total participation when all the entities from a set participate in the relationship set. For example, the participation of a set course in a relationship set taught by can be said to be total because every course must be taught by the faculty. Partial means when it's not necessary for all the entities from entity set to participate in a relationship set. It is termed as partial participation. So this is your diagram. This is strong entity, this is weak attribute, key attribute, derived attribute. This is total participation. This is partial participation. Relationship, identifying relationship, composite attribute, multi-valued attribute. When the size of the database are large, the database are required to be stored on a secondary memory of the computer, such as hard disk. File organization is a way to arrange on the disk, and access methods is how the data can be retrieved based on the file organization. Kritika, can you hear me? Hello?
Yeah, we can hear you.
Okay, I think I was on, my speaker was off, I guess. That's why I couldn't
Yeah,
hear you guys. Sumaya, can you read this?
yes. Physical database design. The database design involves the process of logical design with the help of ER diagram, normalization, etc., followed by the physical design. The key
Sorry,
issues
I
in
think,
the
I'm sorry to interrupt you. Am I on the right slide or I missed that? No, I'm on the right slide. Fine. Yeah, go on.
The key issues in the physical database design are: the purpose of physical database design is to translate the logical description of data into the technical specifications for storing and retrieving data for the DBMS. The goal is to create a design for storing data that will provide adequate performance and ensure database integrity, security, and recoverability. Basic inputs required for physical database design are normalized relations, attribute definitions, data usage, entered, retrieved, deleted, updated, requirements for security, backup, recovery, retention, integrity, DBMS characteristics, performance criteria such as response time requirement with respect to volume estimates. Can you add Kritika back?
720.
Yes, 720.
Okay.
Thank you.
Welcome. If I opened the wrong one, sorry. I hate this boring file organization. Let's just get over with it quickly.
Physical records. Physical records are the group of fields stored in adjacent memory locations and retrieved together as a unit. These are stored in the secondary storage devices. The issues relating to the design of the physical database files. Physical file is a file stored on the disk or SSD. The main issues relating to physical files are constructs to link two pieces of data, sequential storage, pointers, file organization, how the files are arranged on the disk, access method, how the data can be retrieved based on the file organization. Database storage on HDD or SSD. The databases are stored persistently on HDD or SSD if they are very large. Primary storage is expensive or they need to be stored using the non-volatile storage. Each hard drive is usually composed of a set of disk platters. The entire disk can contain a large amount of data, which is organized into smaller packages called blocks or pages. A block is the smallest unit of data transfer between the hard disk and the processor of the computer, having a fixed assigned address. A solid-state disk is made up by using flash memories. These SSD devices also provide similar block-oriented access to data. However, since they do not have physically moving component, they provide lower latency and lower access time than that of disks. There are two basic ways of storing a record on the disks. Fixed length records, all the attributes are assigned equal space in terms of bytes. A variable length record, each record of a table may be of different length. Some attributes may be null. File organization is used to organize the content of a file on a secondary storage device. Main objective of file organization are records that can be selected with ease. CRUD should be easy, avoid record duplication in result, and efficient storage of records. Using the primary key, we can access the records. The type and frequency of access can be determined by the type of file organization, which was used for a given set of records. Some of these file organization types are sequential, indexed, heap, hashed. Sequential file organization. In this method, the files are stored in sequence or consecutively by the primary key field values. This kind of file organization works well for tasks in which nearly every record of the file is required to be accessed, such as payroll system. It is fast and efficient when dealing with large amounts of data that need to be processed periodically at the system. Operations on sequential file organization. File creation, it will be efficient if transaction records are ordered by record key. Record location, as it follows the sequential approach, it is inefficient. On an average, half of the records in the file must be processed to locate a record. Operations on sequential file organization. Record creation, it will require you to browse through all the records to check if such record already exists or not. Thus, entire file must be read and written. Efficiency improves if a group of records are created together. This operation could be combined with deletion and modification and transactions to achieve greater efficiency. Record deletion, entire file must be read and written. Efficiency improves with greater number of deletions. This operation could be combined with addition and modification transactions to achieve greater efficiency. Record modification, very efficient if the number of records to be modified is high and the records in the transaction file are ordered by the record key. Update, insertion, and deletion of records in a sequential file require a new file creation. Can we reduce creation of this new file? Yes, it can be done easily if the original sequential file is created with holes, which are empty record spaces as shown in the figure.
Okay.
Indexed file organization. It organizes the file like a large dictionary. That is, records are stored in order of the key, but an index is kept which also permits a type of direct access. The records are stored sequentially by primary key values, and there is an index built over the primary key field. To locate a record in a sequential file which is not indexed sequential, on average you may read about half the number of records. Therefore, retrieval of a specific record in a sequential file is inefficient, especially if the file has very large number of disk storage blocks. The use of index in a sequential file improves the query response time by adding an index, which is defined as a set of index value address pair. An index is a mechanism for faster search, as the size of index is much smaller than the original file. Hashed file organization. Hashing is the most common form of purely random access to a file or database. It is also used as an optimization technique to access columns that do not have an index. Hashing involves the use of a hash function. Input to a hash function is the value of the attribute or set of attributes of a record that are to be used for file organization, and the output is the block address or page address where that record can be found. Insertion or search on hash key is fast, but range search is slow and it suffers from disk space overhead. Use of an index in DBMS. Indexing is used to optimize the performance of a database by minimizing the number of disk accesses required when a query is processed. For example, a book has a table of contents to find them easily. The index is a type of data structure. It is used to locate and access the database in a database table quickly. Indexes can be created using some database columns. The first column of the database is the search key that contains a copy of the primary key or candidate key of the table. The values of the primary key are stored in sorted order so that the corresponding data can be accessed easily. The second column of the database is the data reference. It contains a set of pointers holding the address of the disk block where the value of the particular key can be found.
Okay. So, Sumya, you can see that in the question paper, I think it's asking use of indexing in DBMS. And I think the only two use mentioned here. Maybe see if you can add one more use.
Okay,
So this one is important indexing. So I think we studied yesterday. It's very clear, and every now and then they're just mentioning this key thing that indexing is just like your book, where a book has an index. You can easily locate any particular page by just knowing its index. Similarly, in database also, a separate indexing is created which contains two things: your search key, which will contain some of the key attribute from the table, and the data reference could be the reference of either the memory address of either that particular tuple or record, or it could be the entire block which contains multiple records. And what's the use of this? It's basically used to optimize performance by minimizing the number of disk accesses. For example, if you had to go and read each and every record, it'll take more time compared to if you just had the key of that, uh, and then just directly go into that block. An example would be, let me show you, where is it? Yeah. Let's say this one. So let's say, we are looking for a record that is 351, ending with 351. So if the database has to search for it, where does 351, uh, where do you think you can find it? So 351 is basically after 348, and it's before 353. So it's very clear that you'll be able to find it in this record. So it doesn't have to search all of this. It knows. If it knows the block address, you can directly go here. It doesn't have to look at all others or even before. Or maybe let's another example, a better example would be this one, let's say. So this one is what? Yeah, this one. 15. Yeah, let's say you're looking for a record which is 017. So 017 of course will be before 616 but after 015, so it can directly go into this block and don't have to worry about the top ones and the bottom ones. So that's how it's saving time and improving performance, because it can directly go to that particular block. It has the address using the index of that block. Okay, so that's how it's minimizing the number of disk access required when a query is processed. Index is a type of data structure. It is used to locate and access data in the database quickly. Indexes can be created using some database columns. First column is a search key, which can contain the primary key or candidate key of the table, which is this one, this one right here, and the value of the primary key are stored in the sorted order so that the correspondence data can be accessed easily. And yeah, sorting is really important, because if it's jumbled up, then that logic which I explained will not be applicable here, because then you will not know which block to go on. Second column of the database is a data reference. So the second one is basically the reference to that block. So this will have the memory address of this block. So once we know we have to search in this block, rather than searching the whole database, now I only have to look at these 5 records and just quickly find it. That's why indexing is so useful. It contains set of pointers holding the address of the disk block where the value of the particular key can be found. I think indexing is clear. There are different types of indexing: primary, clustering, secondary. I think in the exam there's a question that uh, which is better, primary index or secondary index, which we will discuss in some time. Primary has dense and sparse. Okay, so Maya, go on.
In primary indexing, the index is created on the basis of the primary key of the table. We store the first primary index of a block and the block pointer address pointing to that block. These primary keys are unique to each record and contain one-to-one relation between the records. As primary keys are stored in sorted order, the performance of the searching operation is quite efficient. The primary index can be classified into two types: dense index and sparse index. The dense index contains an index record for every search key value in the data file. It makes searching faster. In this, the number of records in the index table is same as the number of records in the main table. It needs more space to store index record itself. The index records have the search key and a pointer to the actual record on the disk. A sparse index: in the data file, index record appears only for a few items. Unlike dense index, where each item points to a data record in main table, in sparse index, each item points to a block in a gap. Clustering index. In clustering index, two or more columns are grouped together to uniquely identify the records. A clustered index can be defined as an ordered data file. Sometimes the index is created on non-primary key columns which may not be unique for each record. In this case, to identify the record faster, we will group two or more columns to get the unique value and create index out of them, and it is called a clustering index. These groups are called clusters. The records which have similar characteristics are grouped, and indexes are created for these groups.
So I think all it's saying is that it's the same behavior as a normal indexing, but multiple columns are keys are grouped together and added here, which have similar characteristics. Now we talk about secondary index.
In secondary indexing, to reduce the size of mapping, another level of indexing is introduced. In this method, the huge range for the columns is selected initially so that the mapping size of the first level becomes small.
Hmm.
Then each range is further divided into smaller ranges. First level, large range of numbers are selected. Then the mapping of the first level is stored in the primary memory so that address fetch is faster. Second level, the mapping of the second level and actual data are stored in the secondary memory or hard disk.
Okay. I'm just wondering if it's saying that a huge range of columns is selected initially. So are they talking about the primary level? It looks like this has more number.
Yes, I don't know, I haven't understood it properly.
It's a bit confusing here because here is
Yeah,
saying large number of numbers are selected in the first level, but looks like first level is this one. Right? I don't see the large numbers here. There's some confusion. One thing is clear that there are two level of indexing is done. First, they select the large number, and then out of that large number, they again narrow it down to a smaller number of indexes.
yeah,
Yeah.
I, I
See, if,
think it I think it means that in the first table, in the
uh,
first table and the second table, so for 100, the pointer is between 100 and 200, and then in the
yeah.
next step, and that is by and that further divides by in the range of in increments of 10, and in the third table it is in increments of 1.
Mhm.
So
Third
uh,
table, I think, is the main table where all the record is
mm,
there. We are
no,
only talking about
that's the secondary, right? Secondary can be multiple. I,
uh,
I thought that it meant that. I'm not fully sure, but from the numbers, it seems to match. Like between 100 and 200, if you, in the first table, it points to increments of 10, and then it
hmm.
further divides into increments. So I'm assuming that in the first table there was 100, 100, like in the original database table there was 100, 102, la 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 till I don't know whatever number, and that was divided into multiple secondary indices.
Okay, so what you're saying is when it's talking about huge range of column is selected is the primary one, correct?
Yes, yes.
Okay. Okay. If that's so, then yeah, then everything makes sense. So huge number of columns are selected, and then each range is further divided into smaller ranges. The size
And
of the
that is
first
divided
level becomes
into
small.
more smaller ranges.
Yeah, I think what you're
Yeah.
saying makes sense because here it's next statement is attached to it saying that the mapping size of the first level becomes small, and this is small. Yeah, correct.
Yes.
Absolutely. So we established that huge range of column is selected, which is this primary level, which is stored in the primary memory, and this is a smaller range, and then each range is divided further into small ranges like this, which is the secondary level, which is stored in the secondary memory. Okay, perfect. So that's helpful because of group study. We could solve this problem. Another advantage of group study is that when I was solving that problem in the SQL Bolt, and I couldn't solve that, I was putting equal to, and so Maya suggested like. So
Hmm.
now I will never forget now that because somebody corrected me, right? So in the example
Even I'll never forget that.
component,
yeah. These sessions are really helpful.
yeah. Sometimes we may think that we understand correctly, but it's when we discuss, you know even though the other person doesn't tell us, but because we are kind of it's called rubber duck effect.
Yeah,
If you see that on the internet, what's rubber ducking is. Rubber ducking is that if you're not able to solve a program, or a problem is for programmers, then you tell that problem to someone. So when you hear it out yourself, then you yourself will be able to find the solution of that, because when you're explaining it to someone, you automatically understand, okay, so probably it should be done this way. It's rubber ducking. Okay, this is again a question from examination. uh, Maybe Sumaya, if you can add an example for this, that'll be great. It's saying justify with example.
Okay.
Okay, so if two indexes were created in database, one on the primary key and second on the secondary key, which of these two indexes will be more advantage? So we established that a primary key one is where uh, one particular key, either a candidate key or primary key, is selected when creating an index, and then second column will be the address mapping for that particular block. And in the secondary, we know that uh, it's basically divided into small number of indexes, and then it's further divided into another range, which is in primary and secondary indexes. So let's say which one is better. So primary index is an index or set of fields that includes unique primary key and is guaranteed not to contain duplicates. In contrast, secondary index is an index that is not primary index and may have duplicates. Searching data using primary index is efficient because it stores data in sorted order. Primary index requires the rows in data blocks to be ordered on the index key, while the secondary key does not have an impact on how the rows are actually organized in the data block. Moreover, there is only one primary index where while there can be multiple secondary indexes. So now we have to add the diagram. So what did we establish? Which has better advantage? The first one, right? Which is in the sorted order. Okay, I'm going to skip this. Kritika, can you read this?
Yes. Implementing index using tree structure, binary search tree as indexes. A binary search tree is rooted binary tree data structure with the key of each internal node being greater than all the keys in the respective node's left subtree and less than the ones in its right subtree. A node on BST stores the key value address pair. A BST as a data structure is suitable for an index if the complete index is contained in the primary memory. However, if the indexes are quite large in nature and require a combination of primary and secondary storage, then you can use B-tree data structure to implement the index. B-tree is a self-balancing search tree used to reduce the number of disk accesses. Since the height of the B-tree is low, so total disk accesses for most of the operations are reduced significantly compared to the binary search trees, balanced binary search trees.
Kritika, can you this? They might ask this question in the exam. I know it's not come into assignment um, or the question paper. They might ask this B tree and B tree data, etc. Can you
Hmm.
probably take help from some YouTube videos and just explain this to us tomorrow?
Yes,
So
okay.
write something in the
Right.
structure. Okay, you can make a note of
Yes,
it.
okay.
Okay, go on.
Multi-key file organization. Multi-key file organizations allows access of records on more than one key fields. Two of the commonest techniques are multi-list file organization. A multi-list file maintains an index for each secondary key. The index for secondary key contains, instead of a list of primary keys related to that secondary key, only one primary key value related to that secondary key. That record will be linked to other records containing the same secondary key in the data file. The multi-list organization enhances the query answering capability of databases on multiple key values. The number of records in an index entry determines the length of the index on a specific attribute value. This enhances the performance of searching when more than one search terms are used, as you can select the smaller list and then apply the second search term on it. Inverted file organization. An inverted index is an index data structure storing a mapping from content, such as words or numbers, to its locations in a document or a set of documents. This file organization is somewhat similar to that of multi-list file organization, with the key difference that in multi-list file organization, index points to a list, whereas in inverted file organization, the index itself contains the list.
Okay.
Okay, importance of file organization. To implement a database efficiently, proper file organization is essential. There are several important consequences of an inappropriate file organization being used in a database. The wrong file organization will result in much larger processing time for retrieving or modifying the required record, undue disk access that could stress the hardware. Okay.
We will
Integ-
study this for another 5 minutes. Then we'll jump on to Java. We'll do that for half an hour and we'll call it a day.
okay. Integrity, functional dependence, and normalization. Data integrity relates to the correctness of data and often is implemented using constraints on attributes and one or more relations.
So, Sumaya, I was asking you this question: what is the meaning of database integrity? So, in one or two words, it means correctness of the data. And how is it ensured? It is ensured using the constraints, by implementing the constraints on the attributes. That's data integrity, which is correctness.
Data integrity relates to the correctness of the data and often is implemented using constraints on attributes and one or more relations. Two important integrity constraints of a database: entity integrity constraint, and the entity integrity constraint states the primary key value can't be null. This is because the primary key value is used to identify individual rows in relation, and if the primary key has a null value, then we can't identify those rows.
I think we already studied this, right?
Yeah,
The
yes.
entity. There's another one called referential.
Referential.
That was to do with the all like the attributes in the first relational instance of a primary key. If it's mapping with the foreign key, then it must be available at least in one of the tuples,
Yes. A table can contain a null value other than the primary key field.
which means except primary key column, others can accept
Null.
null value. Okay, referential.
A referential key integrity constraint.
Yeah.
A referential integrity constraint is specified between two tables. In this, the database must not contain any unmatched foreign key values. For example, any value existing in the employee ID attribute in assignment relation must exist in the employee relation.
I think this is a more simpler uh, way of explanation compared to the way we have described there. So I think we should copy paste this there. So remember this slide number 80. Where is that slide? Remember? Yeah, here. This, this is a little complex. This is better one we have. What was it? 80, right? Okay, we'll jump on. Database
Yes.
modification says deleting insertion can cause violation of referential integrity. Okay.
Redundancy and associated problems and solutions. When some information is repetitive in a database, it has undesirable data redundancy.
What is the solution for this? Let's say some data is repetitive in a table. How does relational database management system solves this problem?
Modify, delete, update,
No, no.
and there's one more.
It's saying when some information is repetitive in database, so it's called redundancy, right?
Yes.
Where
We
things are
can
repeating in the table.
uh, we can create a separate table.
Yes. Yes. And what is that process called?
Normalization.
Absolutely. Absolutely. So normalization is the solution for data redundancy.
Problem. Such repetitive information not only increases the size of database but also results in several problems such as update anomaly. If the information of a record changes, we may have to update the same record at multiple tuples. Otherwise, it may contain data inconsistency.
So normally you can think of like a problem, update problem. It's actual meaning is deviation from standard, but update problem, like what will be the problem in updating the data if there's repetitive data available? So if the information record changes, we have to update the same record multiple times.
Insertion anomaly. As per entity integrity constraint, any new tuple to be inserted in the relation must have a value for both the attributes of the primary key. Sometimes both information may not be able to be added. Example: adding course ID until student enrolls for a course. This problem is called insertion anomalies.
Right. So new tuple inside relation must have both attributes, a value for both attributes of primary key. So let's say, for example, there is a tuple, there is a row in which contains attributes such as student ID, student name, and the teacher name, or maybe course name. Forget teacher, course name and course ID. Okay, so a new course is introduced, and I want to feed the data of that course into the database. Okay, but none of the student have enrolled into it. So how will I add the data? So in that row we have. Let's show you quick here. Mm, I'll put it here, or maybe I'll just open a drive and show it to you. So this will make it clear. So let's say we have a table in which you have student ID, you have student name, then course name, like which course he's enrolled to, and course ID. Okay, let's say student ID is 1, student name is Ravi, course name is Java, course ID is 2. Okay, let's say there is a new course introduced in the college, and the course name is DBMS, and I want to insert the record of DBMS. Now, entity integrity constraints states that none of the records or none of the tuple value, you can't put this is the primary key. You can't make primary key as null, right? That's what we established. So I have the course name, which is DBMS. I have course ID, let's say 3, but I don't have the student name and student ID because none of the students is enrolled to this course, just a new one. So I'm stuck. And that's your insertion anomaly. And I can't insert this data because I can't have this student ID as null because none of the students have enrolled and I can't put student name here. That is a problem, and we solve this problem through normalization by breaking this into multiple tables. So I'll take this out, I'll move it, I'll call it like subject table or course table, courses relation, and here I will just put course ID. I'll put, so now I don't have to worry about anything. I can put like that. If a new course comes in, I can add that here. Another comes in, I can add that here. And later on in the future, if student enrolls for it, uh, then I can just put the course ID over here like that. So now with the help of course ID, I can get all the information about that course, even the description or whatever I want with the join operation. So that was the problem. Uh, and this is the solution. Normalization is a solution. Is decomposing a table into multiple ones. Understood?
Yes.
Cool. Moving on.
A deletion anomaly. Loss of useful information is called deletion anomalies. Example, deleting a student tuple can also delete his course details, address, etc.
Okay, so again, going back to the same example, let's say I had two students here. Uh, I want to delete student record, this student record basically. Okay, now in the entire table, I don't have this course data anywhere else. Okay, so that's the only place if I delete this student record like that, I will lose the course related information also. So I'm losing that data, and that's what's talking about deletion anomaly, deletion problem. That if I delete a record, everything else along with it, which may be needed later on, is gone. So loss of useful information called deletion anomaly. Deleting a student tuple must also delete his course details, address, etc. Solution.
Sorry. A solution. The anomalies arise primarily because the relation student has information about students as well as courses. One solution to the problem is to decompose the relation into two or more smaller relations so that a relation contains information about one thing. The dependence among the attributes forms the basis of decomposition of a relation into two or more relations, and it is called normalization.
Okay. I think we'll stop here for DBMS and we'll continue with the Java because it's important to revise. If you don't revise, then if those information is not going to be retained into our head, if it's not retained, then it's no use spending so much time. So revision is more important than just studying. So if we learn 10 things, but if you revise and it gets retained, that's better than reading 100 things and not remembering even one. So let's move on. I think we did throw and throws. So we'll go to packages and interfaces. Uh, Kritika, I'm giving you right access for this one. Be very careful in editing the data. Once you're done, I'll remove the editor access from your side. So do the same thing for this one also, which is just change the background color for the ones which are important. Okay, later on.
Okay. Mm-hmm.
This is three times important. What is the package? You know what
What
three
is
times important is? It's there in
no?
the assignment as well as in the paper.
Okay. Right.
Okay,
Okay.
let's go.
What is a package? A package is a collection of similar types of classes, interfaces, and sub packages in Java. It is just like a folder in a file directory.
Okay, so it's a collection of classes, interfaces, and sub packages.
For example, when you write an application program in Java programming language, there may be many individual classes. You can place related classes into a folder and name this folder for organizing these classes. Now it is called a package. Packages are used to avoid name conflicts and to write better maintainable code.
Yeah.
Access or accessibility rules for packages. You can limit the access of classes, methods, and variables throughout packages by using access specifiers. The three main access modifiers, private, public, and protected, provide a range of access required by these categories. You can declare anything as public, then it can be accessed from anywhere outside the package. Anything declared as private can only be seen within that class. If you declare it protected, then the code is accessible in the same package and its subclasses present in any other package. When you do not mention any access modifiers, it is called default access modifier, which is visible to subclasses and the other classes in the same package.
Okay, so just a recap of this. So when it's default, it's available uh, to the subclasses and other classes in the same package. So default means it has to be within the same package. Public means it can be within and outside that package. So key difference in public and default. They look similar, but they are not. So default, think about that. It has to stay within the package. Public means publicly available, within or outside the package. Private, private means completely private. It will be only within that class, unless you use getters and setters to extend it. When you extend it, if it's protected, then it's only accessible in the same package and its subclass present in the other package. So here you can move out of the package, but it has to be the class which is extending that particular one for protected. Okay.
Finding packages and class path. Java runtime system looks for packages from three paths. Current folder. First, the Java runtime system uses the current working directory as its starting point. If your package is in a subdirectory of the current directory, it will be found. Class path. Second, you can specify a directory path or paths by setting the class path environmental variable. Class path. Third, you can use the class path option with Java and Java C to specify the path to your classes.
So let's say in this example, you create a package called mypack. This is your custom package. In order for the program to find mypack, one of the three things must be true. First, either the program can be executed from the directly immediately above mypack. So if it's in the directory above, okay, the directory above the mypack, it can be executed from there. Or class path must be set to include the path of mypack. Or third thing is, you should use hyphen class path option, must specify the path to mypack when the program is run. When the second two options are used, so this is the condition. When second two options are used, which means you're using the class path hyphen or this capital letter class path, then the path must not include mypack at the end. Okay, it must simply specify the path to mypack. So this is the example where you're not putting mypack at the end if you're using class path or hyphen class path. But in the normal situation, if you're just specifying the path to the folder, then you have to mention the name of the package. Okay.
Types of packages and creating a package. There are two types of packages in Java. Built-in packages are packages that are the packages from Java API. For example, such as Swing, Util, Net, IO, AWT, Lang, JavaX, etc. Importing a package. import package.name dot star semicolon example import java dot util dot star semicolon.
So dot star means it'll import all the classes which are there in that package. But if you want to get only a specific one, for example, java.util.scanner, you only want scanner. Then instead of star, here you will put dot scanner. So it's only going to give you access to that. If you put star, then all the classes or interfaces within util will be available to you to use.
User defined package, create your own packages. Creating your package, a package can be creating by using the keyword package followed by the package name, package first package semicolon.
Yeah. So if you have created a class file and you want to put that in a package, all you have to do is at the top of the file, just put this line, which is package, and whatever name of the package you want to call it as. In this case, first package. So that's your custom package. And there are some default packages which are built in, like you java.util, java.swing, java.net, java.awt, and so on and so forth. These are built in the Java library. So this is an example of creating the package. To create a class inside a package, first we declare the package name as the first statement of the program. Then we include a class as a part of the package. So here you can see that at the top of the file you put package first package, and this is your general definition of the class. Whatever program you write, you can continue writing. So if you want to do it from the command line interface, you can see Java welcome.java, Java hyphen d welcome.java, and Java first package.welcome. So this just explains what it does. This will generate the output of the above program. The above command will give us welcome.class file. Command will create a new folder called package. Above will give final output. Okay.
Interface, an interface in Java is a blueprint of a class containing static constants and abstract methods. In Java, an interface is syntactically similar to classes, but they lack instance variables and their methods are just declared without having any body. It means that the interface can contain only constant declaration, method declaration, default methods, static methods.
So, Abhi, interface, if I had to explain to you, how do I explain to you? Okay. Let's say you have to do an assignment for five different subjects. So, for IGNOU, okay, so you go and buy five different copies, five different notebooks. Okay. Now, let's say there are five questions uh, in each of the assignments. So, for the first assignment, what you do is you put question number and you say answer and you leave some space there. You don't actually put the answer. On the second page, again, you do the same thing. You put second question, yeah, and then you leave the space for the answer. You don't actually do it. And third one, same thing, and the fifth one, same thing. So what are you doing? You actually kind of preparing yourself as to what needs to be done next, uh, and you're not actually doing that thing. So same thing with the interface. Interface is kind of just definition. uh, so we are going to have maybe multiple things which will have similar kind of methods. So implementation will be done later, whichever class implements that interface. So it just creates the interface and it defines that method, but it actually doesn't. That method doesn't do anything. It kind of keeps the body empty, and that's what it's talking about. Interface is similar to the class, but they lack instance variables, and methods are just declared without any body. When will this be done? It will be done by the class that implements it. So the class that implements it, that is what is going to implement his body. Maybe it's not a perfect example I gave you, but at least just to bring your head outside of this piece of information to make it understand to you. Okay.
Advantages of using an interface. It is used to achieve total abstraction. Since Java does not support multiple inheritances in the case of a class, By using an interface, it can achieve multiple inheritances. It is also used to achieve loose coupling. Abstract class and interface. The difference: abstract class can have abstract and non-abstract methods. Interface can only have abstract methods. Since Java 8, it can have default and static methods also. Abstract class does not support multiple inheritance. Interface supports multiple inheritance. Abstract class can have final, non-final, static, and non-static variables. Interface can only have static and final variables. Abstract class can provide the implementation of interface. Interface can't provide the implementation of abstract class. The abstract keyword is used to declare abstract class. Interface keyword is used to declare interface.
ये
An
खाली लिख देना
abstract
है, एक नंबर मिल जाएगा। ये वाला इजी है।
hmm,
ओके, go on.
declare interface. An abstract class can extend another Java class and implement multiple Java interfaces. An interface can extend another Java interface only. An abstract class can be extended using keyword extends. An interface can be implemented using keyword implements. A Java abstract class can have class members like private, protected, etc. Members of a Java interface are public by default. Example: public abstract class shape, curly brackets open, public abstract void draw, brackets semicolon, curly brackets close. An interface, the example is public interface drawable, curly brackets open, void draw, brackets, colon, and
Okay,
curly
so as
brackets.
you can see, if you don't define the access modifier of any method, it is considered to be as default. So here we have not put any public private. So saying it can have default method. So that's why this is default. Okay, declaring and implementing an interface. An interface is declared by using interface keyword. It provides total abstraction, means all the methods in the interface are declared with an empty body. So think of that example I gave you. You write the question but not the answer. You keep the empty body. So you can maybe describe this part. And all the fields are public, static, and final by default. This is an example. You create an interface with the keyword interface, interface name, declare constant fields, methods, etc. Interface printable, void print. This A6 class implements printable, and it has to implement the class print. That's the rule. But if you implement a particular interface, then you have to implement all of its methods. So implementation means you have to define its body over here, like so. Then you just instantiate this particular class, and automatically it will have access to this void print method. Okay, extending an interface. An interface extends another interface, like a class implements an interface and an interface inheritance using a keyword extends. So you can not only implement an interface using implements keyword, but you can also extend an interface. So extending means you can inherit it. So then the inherited interface will have not only its own methods, but it will also have the parents' methods. So here's an example. B extends A. So now B will have function A and function B both, and the class that implements B must implement both the methods, because now A is part of B also. So that's what it's doing here, and then you're accessing those functions. Same thing what I just explained. Defaults interface methods. Hey, this looks new. Defaults interface methods. Sumaya, did you add it?
No, it was there before.
It was? Okay. Default interface methods. If a new method is to be added in interface, then its implementation code has to be provided in the class implementing the same interface. To overcome this, Java has introduced concept of default methods. which allow the interface methods to be implemented without affecting the classes that implements the interface. Implemented classes do not have to implement default methods. Okay, all it's saying is that uh, there is a rule that if you extend an interface, then you must implement all of its methods. But there is a additional clause with that. If a method is default in the interface, then you don't have to implement it. So that is why you have to implement method 1 because it's not default, but you don't have to implement method 2 here. So you can see method 2 is not being implemented because it's default. So that's a rule as per Java 8. Issues of multiple interfaces. Java does not support multiple inheritance as we discussed earlier. For example, if a class inherits two classes which have the default method each, upon calling the method of the compiler cannot determine which class's default method to be used. To solve this, we can use multiple interfaces. If both interfaces contain default method with the same signature, the implement class should specify which default method to be used or should override it. So we can do that using super method. Use of static method in an interface. The interface static method is similar to the default method of an interface, but it cannot be overridden in the implementation class. The static method contains complete definition of the function, and since definition is completed, the said method becomes static. Therefore, these methods cannot be overridden in the implementation of the class. So all it's saying is that if you declare a method as static, if you give the if you declare it as static, then you cannot override it in the implemented class. So for example, this hello. So you cannot override this one. You can call it, but you can't override it. Multi-threading. Multi-threading is a Java feature that allows concurrent execution of two or more parts of the program, which means two or more parts of the program get executed simultaneously for maximum utilization of CPU. Each part of such program is called a thread. So threads are lightweight processes within a process. Multi-threading system in Java is built upon thread class and its methods and its companion interface runnable. So when you want to create a thread, we'll learn later that you need to either uh, extend the thread class to create a thread, or you need to implement the runnable interface. To create a new thread, your program will either extend thread class or implement the runnable interface. The thread class defines several methods that help in managing the thread. Explain Java thread model with the help of an diagram. A thread in Java has three components: CPU. This is what you've written, Sumaya, right?
Yes.
Okay. Explain Java thread model with the help of a diagram. A thread in Java has three components: CPU. Thread class is designed to encapsulate the virtual CPU in it. When a thread is constructed, the code and the data that define the thread specified by the object are passed to the constructor of the thread class. Data may or may not be shared by multiple threads. Code shared by multiple threads independent of data. A thread can be in various states: new, ready, running, blocked, and dead. Where is the diagram? Is this the diagram?
Yes, this is the only diagram in the book.
So this is what we'll use there, right?
Yeah.
So maybe we can paste this diagram there. Was there any like diagram available in the on the internet?
No, I found the same diagram of the thread states.
Okay, no problem. Java thread model, thread states, thread life cycle. So just like your processes, a thread exists in different states. You have new, a thread in new state when it gets the CPU, the CPU gets assigned to it. Running, when a thread is in a running state, when it's under execution. Suspended, a thread is in a suspended state when it's temporarily inactive or under execution. Blocked, a thread is blocked when it is waiting for a resource. And terminated, when a thread becomes in this state when it's given time, when at any given time it halts its execution immediately. So it starts in the new state, I guess, when CPU gets assigned, then it's ready to be executed. This is the running state under execution. Suspended or waiting state, waiting for some resource, uh, or could be blocked also. And then dead with terminated, which means it's finished its execution. How threads are created in Java, like I explained earlier, you need to either extend the thread class or you need to implement the runnable interface. So this is an example of a program. Uh, so here we are extending the thread. We are actually overriding the run method of the thread class using try and catch block to catch the exception. You first calling a method of this class called current thread.getID. This is going to get us the ID of the thread, and it's going to print that. If there's an issue, it'll catch that exception. Then in another class called multi-thread, we instantiate the this particular class that we have extended, and using the method start, which belongs to thread. When this start is called, then the thread is created and it starts running. So it invokes the run method. When you call start, it'll invoke the run method, and then the thread will be thread ID will be printed here. So we create a class that extends java.lang .thread class. This class overrides run method available in the thread class. Same thing which I explained. Thread begins its life inside run method. We create an object of a new class and call the start method to start the execution of the thread. Start invokes run automatically. Now this is, so we discussed there are two ways to create a thread. One is extending the thread class or by implementing the runnable interface. So now we're going to look at the second way of creating a thread, which is implementing the runnable interface. Sumaya, you have put this one, or I have put it? This guy.
I put that it's the answer to the to one of the questions in the question paper. Write a Java
I
program.
have understood how the thread is created. Setting the priority, right?
Yeah.
Okay. So we'll only look at this one then. We don't have to look at two of them, right? Should we delete this one?
Uh,
Let's
yes.
keep let's
Only
keep it.
in mine I've not put try and catch.
Okay, that's right. Let's keep both of them just for reference.
Okay.
Let's look at this one. So we're implementing runnable. We are overriding the run method of runnable, trying and catching thread dot current thread dot get ID. Same thing what we did when we were extending the what is called thread class. And then in multi-thread we are looping through it and setting the value of n equals 8, instantiating the thread class and passing the multi-thread demo as a parameter, calling the start function is going to invoke the run and execute this, and that's what's happening. In the examination question paper, it's asking write a Java program to demonstrate how thread is created, but set the priority to create the thread. If we didn't have this line, we could have used this example. Because it's asking us to set the priority of a thread, we'll go with this example. Same thing what we have done here, which is implementing runnable. We are printing the current thread dot the name of the thread, and there is a method available in the thread class called get priority. So we are going to get the priority here. So we're going to print both. We're going to print the name of the thread as well as the priority. So now over here, we are going to instantiate thread class, pass my thread into it, which is the interface. And it takes second parameter as the name of the thread, which is child thread. Then we set the priority using the set priority method, and pass the new priority as 8. Ignore this name. Don't put this name in the examination. This is by default. VS Code tells you what type of parameter it is. So anything that's highlighted, don't put that in the exam. Just directly pass it. So you pass 8 as a parameter, and then when you call start, then run will be invoked, and this will be executed. So when this gets executed, child thread running, priority is 8. Notice that here the thread is only printed once because we didn't run a loop like this. If you were running a loop like this, then we would have created 8 different threads. But question is not asking that. Question is just saying how to create a thread and set the priority to 8. So we just created one thread and set the priority to 8 using this function set priority. Here we are setting the priority, and here we are getting the priority. So after we set it, we want to know if the priority is set properly or not. That's what we are calling get priority method here. So that's what's being printed. Okay, I think we'll stop here. And reason we spend like 2.5 hours because exam is coming close. Weekends usually people have more time. So tomorrow we meet at the same time 6, and we kind of start with the revision. Uh, so just a recap, Kritika, you will be explaining us about what topic? There's one topic I gave you, right? What was that? B tree, right? So remind me if I forget tomorrow. And Sumaya, you will be covering normalization tomorrow, right?
Yes.
Okay, cool.
Should I cover all the normal forms, fourth and fifth also?
Yeah, I think it's better. Let's cover that. You never know these guys. I can't trust them anymore based on what happened
Okay.
last time. Yeah, let's just cover everything. We don't have to cover too much because, as you can see from the paper, the number of marks they are giving is not like too much. It's either 4 marks. Where is it? No, 6 marks actually. 6 marks. So 6 marks means they're giving two things to describe: second and third normal form. So 3 marks for each. You can consider like in 3 marks how much you want to write for each normal form. Here is 2 marks. So in 2 or 3 marks, whatever content is required. But definitely one thing that we definitely need is the example. Because every damn question they ask for example. I don't know what's wrong with these people.
Okay.
Fine. Yeah,
Yes.
from tomorrow. Yeah, go ahead.
Yes. I was just saying yes. I'll explain binary tree tomorrow.
Yeah.
Yes.
Uh, so from tomorrow we'll basically try solving question papers, revising anything that's important, and we're not going to be focusing on anything that's not been marked as star because first we have to make sure everything that you see here is something we can go and write in the exam confidently. I mean, I want to sleep peacefully on Friday night. So won't realize with all these sessions, if you're attending on a daily basis, your mind is automatically developing that content into your head, and in the exam you will be surprised that how come you're able to write it. So but next week is going to be really really important, these 5 days, because we're doing a lot of revision. Be prepared. It'll be better if you read it and come, because then we're going to asking each other, then it will be easier for you to just say. You'll get prepared better if you just read all these questions beforehand. Cool. uh, we'll also be doing these questions once again, so that probably I will draw them this time. Last time Somaya did it, so this time I will take one of the sessions where I will draw all these ER diagrams and tables, etc. So I also get well versed with this one. Cool then. Thanks everyone, and I'll see you tomorrow at 6.
Thank you. Bye.
Welcome. Bye bye.
Bye.